So, Razor Group aims to identify top performing e-commerce sellers in Amazon Garden category for potential acquisition. So, our goal is to identify the best sellers. So, for this, the key challenges are data parsing and data cleaning, feature engineering, and selecting the best selection criteria for the best sellers. So, first, let's dive into data cleaning. So, our objective is to extract product count from the text format, which is in the text format in the seller product count column. So, we stored this 1 lakh as the numerical product count. After that, we extracted positive ratings from the seller ratings column. So we extracted three columns from this. One is positive ratings and another one is rating count and the another one is encoded as rating period. If it is last 12 months, it is encoded as 1. If it is lifetime, it is encoded as 2. If it is missing column, it is encoded as 0. So like this we encoded three columns from the seller ratings: positive rating percentage, rating count, and rating period encoded. So in this way these three columns were extracted. After this we extracted a phone number and email address from seller details with high reliability. So detecting using a regular expression that matches standard email formats. Also, for to extract phone numbers, when we explicit labels like tel, phone, contact, etc. So if no label number is found, reject patterns, search for common phone number formats, including international numbers, German local numbers, like that. So like that we extract this extracted phone and extracted email. So after this, we will filter out the Chinese address, Chinese business sellers from business address. So these last two characters depicts the business address of that particular seller. So if it is CN, which means China, we will remove filter out those Chinese sellers. Also there are some empty rows, which doesn't mean whether it is Chinese seller or other country. So I added it here a toggle. If we converted it to false, it will it won't remove empty addresses, but if it is true, it will also remove the empty addresses. So in this way the data parsing and cleaning were completed. So after this we did a future engineering. uh, Future engineering. Okay, yeah. In this feature engineering, our objective in this feature engineering, I added new features which contribute to the best sellers. So our objective is to measure the trend in negative ratings over time. So I calculated 12 months negative rating from the 30 days negative rating percentage. Whether it is a positive value increase is a worsening trend. A negative value suggests improvement, which the negative ratings trend has decreased. So in this way, the negative trend feature is added. So and one more feature I am developing is a trust score. Despite developing a composite trust score to access seller reliability. So we are calculating this like positive percentage minus mean of whole negative seller rating. So in this way we will calculate the trust score, and the another one is average negative rating. This calculates overall measure of negative ratings by averaging seller trends over different time frames. So after this we added one more score, that is seller rating score. Because let's imagine let's imagine a seller has 88% positive ratings, but the rating count is almost all 1000. At the same point another seller has 100% positive ratings and it has only 4 rating count. Users all users obviously choose the 88% rating. So that's why I can to to integrate these two columns, I added seller rating score, which create another new column which depicts positive rating into log of 1 plus rating count. In this way it balances them both. So after this I calculated a seller activity score, which estimates seller market presence by combining product count and rating volume. After that, to assess the variety of brands offered by a seller, we calculated product diversity analysis. analysis. So after this, we scaled, we we with Winmax scaler we normalized all the numerical features. After that, we did a selection criteria which established which selection criteria based on trust score, activity ratings, diversity of the newly created features in feature engineering. In this way, we calculated the composite score, which is nothing but a weight of the particular feature of that feature. So by combining all those features, we extracted one composite score, and based on this composite score, we sorted the seller IDs. In this way, we got the top 10 best sellers. It is also storing it as a CSV. So the key differences in top seller selection is in the random weight initialization approach, 496 was the highest composite score, but in the second one, the 496 is not the highest score. 589 appeared, but the correlation based ranking provides a more data driven and unbiased approach compared to random weight initialization. However, the negative weighting of the positive rating percentage suggests potential multi-collinearity issues which should be analyzed further. Additionally, since many top rank sellers lack contact details, refining the selection criteria to prioritize reachable sellers may improve the effectiveness of the ratings. So by this I will conclude my assignment.